All right, we're looking at independent practice 8.5. This is question number 8, the light number 8, if you will. We want to determine whether the two triangles are similar. So you got two triangles down here. If they are similar, write a similarity statement and find the scale factor of triangle B to A. So that's important, actually, the direction. We're going this direction. Okay, let's see. They are not named, so we're going to need to figure out these triangles, the corresponding sides, based on the way that it's drawn. Although I think I'm jumping ahead a little bit. First, determine whether or not they are similar. We have three options to pick from. Angle-angle similarity, side-angle-side similarity, or side-side-side similarity. We need to show that either two sets of angles are corresponding and congruent, two sets of sides form a proportion, and right between them is a congruent corresponding angle, or all of the sides, all three sets can create a set of corresponding congruent sides. So if we look at what we got, we have, in terms of angles, a right angle and a right angle. And really, based on the way it's drawn, and right now our knowledge of trig, we can't figure out any of these other angles. So this one's off the table. Side angle side really looks like a great option here because if you look, the angle on both times is between a pair of sides. So that's really the route I want to go. That said, because these are right triangles, we can use the Pythagorean theorem to find this guy. A squared plus b squared equals c squared. A squared plus b squared equals c squared. But it's extra work. So I really don't want to do that one, even though I could make it work. And again, this guy we can't make work until we really understand trig. So this is the route. This is the efficient route. All right, the angle part should be fairly straightforward. Angle D right here and angle W, those are corresponding and congruent. They're both marked with a right angle notation. They're both 90 degrees. We're good to go there. Then what I need to confirm is that the sides that are around that angle are going to be proportional. So this right here, DE, that is the shorter of the two sides. That's going to correspond to WX, that is the shorter of these two sides, these two legs, in fact. Specifically in a right triangle, the two sides that make the right angle are legs. And then let's see what I have. I have DF. Let's see what I have. I'm going to have WY. Those are the other corresponding sides. That it's the longer leg. So I can set up a proportion with those. I'm going to do 8 corresponding to 6 in the same way that 12 corresponds to 9. And I'm trying to determine if these are the same. Now, oftentimes what I like to do with these is, because to me it's the most efficient when I have a calculator, just divide them out. 8 divided by 6. See if you get the same decimal. It's 1.3 repeating. 12 divided by 9. Okay, they're the same. They definitely equal. And I can see that from the calculator. There's lots of different ways to do it, though. I could also do 8 times 9 and kind of confirm that they have the same cross products. 6 times 12. Look, they become the same cross product, so that demonstrates that it's equal as well. I could also simplify these fractions. 2 goes into both of these numbers, so this becomes 4 over 3. 3 goes into both of these numbers, it becomes 4 over 3. Lots of different ways to do it, but they're definitely equal. So because they're proportioned, they are similar. So, it's similar with a question mark. Here it's yes or no. Yes, they are similar. All right, scale factor. What is the scale factor? So to figure that out, we have to set up a proportion or a ratio in a very specific method. It says B to A. So this is your original, this is your new thing. This is the pre-image, this is the image. Scale factor specifically, slide this up a little bit. Scale factor is the new over the old, or the image over the pre-image. And I'm not sure yet if I set up these ratios in that correct order. So if I go that way, this is the image, that's the new thing. I need to make sure I do 8 over 6. So I did do that. So that does work. So my K, I can find it by doing 8 over 6. So I already know I could simplify that down to 1 over 3, but I don't like to give my scale factor as decimal, especially with that kind of notation in it. So I'm going to do 8 divided by 6. We're just going to make this guy into a fraction. Calculator can do that for us. That's 4/3. That's 1 1/3. I can also just divide it out, right? 8 divided by 2 is 4. 6 divided by 2 is 3. All right, so my scale factor is 4/3. That is greater than 1, so it does make sense that I've got an enlargement. The sides did get bigger. They're 1 1/3 times larger. All right, now I'm writing my similarity statement. Now I have to be really careful here how I name them. It's not already named, so I have to just be very aware. I'm going to say my triangle here, the original. I'm going to go ahead and call it XY, or WXY. I'll go alphabetical, WXY. Now, it's really important that I do corresponding order here, so I'm going to do is similar to. The first letter I have to pick has to be the letter that corresponds with this guy, so it's W. So it's got to be D. And then look, what did I pick next? I picked X, so I went along the shorter leg. So W to X, that means D to E. And then my last letter is F, and that makes sense. I go on the hypotenuse, I go on the hypotenuse. So this happened to work in corresponding alphabetical order, but be careful, that doesn't always happen. You really want to make sure you're looking at the diagram. W, D, X, E, Y, F. Okay, W, X, Y, D, E, F. Okay, I hope that's helpful. Message me anytime with questions. I'll see you in class.